Hello everyone, welcome back to my channel. In this video, we are going to be discussing about the data preparation phase. So what is data preparation? We have got the data set in our environment, but this data set may or may not be clean, and hence for analysis, it is necessary for us to clean this data. Why the data is not clean? Because it may contain missing fields or redundant values that may not be beneficial for us when we are modeling our data. So we are going to be looking how we can prepare our data in Python one by one. First, we see how to add an index field in the Python. Index field is a unique ID for tuples in our dataset that makes the sorting and selection process easier. What is a data frame? Data frame is a 2D tabular data structure with labeled axes. Why we are discussing data frame? Because we are going to be using the shape function of pandas, which returns the dimensionality of a data frame. That's why we had to discuss what is a data frame. So basically it is a 2D tabular data structure. What does shape returns? Shape returns a tuple that represents the rows and columns of the dataset. We will see here. Before that, we need to mount our drive in the Google Colab because we are going to be using the dataset that is in our Google Drive. So we see here how the shape works. So we have imported pandas as PD. We have created the alias, that is PD, and then using the read CSV we are reading in the data set into a var. Now we will see how the shape would work with var. So we run this. Since it has returned 3000, 9 means it has 3000 tuples and 9 columns. Why we use the shape? Because I don't know how many rows or tuples are there in the California housing test.csv, that is our data set. So before making the index field, I needed to know about the range, about the how many rows are there in, so I can apply it in the range function. Suppose say we have, so I will type here this. Now if I want to add an index field, I would add an index column, and using the series and range function I will add the index like this way. Now if I print this, so here this is our data set, and here as we can see we have an index field from 1 to 3000. You can see here I have used 3001 because we are starting from 1, that's why we had to add 1 in the length of the last index. The next part is changing misleading field values. A misleading field value, what does that mean? It means a data within a data set that does not accurately represent the true state or meaning of the data. What does this mean? Let us look at it by an example. Here is a small snippet of code. Here we have a data set in the form of a dictionary. We have an order ID and status. So the status we have shipped, pending and delivered. There are 3 status. But what does this unknown mean? So we are going to be changing this misleading field. It is a misleading field because the pending and unknown basically means one and same thing. So we are going to be utilizing the df status again, and we are using the replace function here and replacing the unknown with pending. How will this work? We will run this. See, this is how it would be worked. The next part is re-expressing the categorical field values. So first, what is a categorical field value? So basically, a categorical variable is a type of variable that takes upon values. For example, here we can see this is a data set, and here we have 3 variables: name, gender and status. It is taking name is taking some values gender is taking some values and status is taking some categorical values. So here this is a categorical type of data. Now what does re-expressing categorical field value means? Basically we are using here re-expression to use the data processing algorithms, because there are many algorithms that works better when the data is in a numerical format. That's why we need to re-express the categorical field values into numeric field values. How we can do this is, we would see here is another example. Here I am reading a data set shopping trends, which is a part of my Google Drive. Here this is the shopping trends data set. First I will read it. Now I would like to know how many categories are here. So there are this many categories. So then I will prepare a dictionary, that is a category numeric. I want to assign the category field, means all these values some numeric values. So I made a dictionary and applied some numeric values to the multiple values, such as for clothing it's 0, footwear it's 1, accessories it's 3, etc. I will run this. Now we have run this, so I will run this selection. This, if we see the output here of the data, so this is our output, and we have here a numeric category that we had used in our dictionary assigned to each category. This is how we can express the categorical variable into numerical form. The next is standardizing the numeric fields. Why we need to standardize numeric fields? Because certain algorithms perform better when numeric fields are standardized, so that the field mean equals 0 and the field standard deviation equals 0. This is basically for the z-score. We are using the shopping trends data set in our code. We would run this. See, this is our data set again. Now I need to standardize this, so I would use a SciPy library, and from there I would import stats, and the stats have z-score, and I will standardize the age variable here. So here you can see I have added a standardized age column from where the values are ranging from negative to positive. This means that the negative values are below the mean and positive values are above the mean. So this is how we standardize the numeric fields. Now the next is outliers. How we would identify the outliers in our data set. So what are outliers? Outliers are basically the extreme data values. I would use the California housing train CSV here, not the shopping trends here. I would import the pandas and numpy here. Then I will calculate the mean and standard deviation here of total rooms. Basically, if I want to see what is my in here, means what does my data set has here. So see, this is our data set, and I want to standardize the total rooms column here. So the next procedure is done here, is that I would calculate the mean and standard deviation using mean and std function, then calculate the z-score using the z-scores formula, and then identify the outliers. That means I would select if the z-score is greater than 3 or less than -3, then it would return the values in the outliers. I would run this code. So this is the output code we have got after running this code. Here we have the original data, which has 17,000 rows, and outliers data, which has 313 rows. That means we have created a outliers data set separately. So this is how we can find outliers in our data set using the Python. So that's all for today's video. Thank you.